What we're really wanting is kind of a mix of things that are greens that have moisture and nitrogen in them, and then the browns we normally think of being dry and being a carbon source, and probably need roughly about 2/3 carbon, 2/3 brown to 1/3 greens. But the problem with most people in composting is that they have a lot of browns. They have the dry plant materials, they have the shredded leaves, those type of things. And so then the challenge to composting comes in, where do we get our sources of greens? And that's where you can bring in, if you have some manure-based fertilizers, happen to be on a farm, those type of things, or you can use some garden fertilizer. You can then add some nitrogen to that mix so the compost pile will function and work. Composting is really all about thinking of it as being alive. And what do things that are alive need? They need food, water, and shelter.
Compost is the ultimate soil amendment. It provides nutrients that plants require and increases the water-holding ability and workability of the soil. K-State Research and Extension Horticulture Agent for Johnson County, Dennis Patton, says compost is often called black gold because of its value in improving garden soil. But how do you build a good compost pile? He says to think in terms of greens and browns. On today's Sound Living, Making Black Gold. Sound Living is a weekly public affairs program produced by Research and Extension at Kansas State University. I'm Jeff Wichman. According to Patton, composting is both a science and an art. Dennis, in terms of composting, a lot of things I think visually come to mind when we hear the word compost, but I guess maybe in the simplest terms, what do we mean by compost?
By textbook definition, compost is nothing more than decayed organic matter. So going through the process of composting, this plant matter, debris breaks down. It could be animal matter too, anything organic. And basically what we get then is a finished product we call compost or humus or organic matter. And it's that material that we want because it's probably the best product to use to help break up our Kansas clays.
And I guess really we kind of think of just throwing everything together, but there really is kind of a chemistry and a science to composting?
Right. When I work with people on composting, I kind of say it's an art and a science. The science is making sure the composting process works, and I think the art part of it is figuring out what works for you. It's a two-step thing, but really it's nothing more than managing microorganisms that feed on the organic matter, and in their process of feeding, break it down and turn it into compost. And I think the aha moment for me and when I train other people on composting is we put dead stuff in the compost pile, but the compost pile is actually very much alive. And it's managing those microorganisms that helps the compost process take place.
And really because of that, we want to make sure that we pick the right location for the compost pile?
Right. There's really not a bad location. There's probably just more of a desirable location. So, kind of looking at location, there's pros and cons of being in the sun versus the shade. Being in the sun, it probably is going to be active longer into the fall and heat up quicker in the spring. Being in the shade, though, decreases some of the desiccation, drying out of materials during the hot part of summer. So I think either place works. Probably the place you want to avoid is a low area that's going to collect water, those type of things, because too much water then takes the oxygen out of the compost pile, turns it into an anaerobic situation, which can lead to an odor or a smell. Most people want to locate it kind of out of sight. It's not something you want to stand at your kitchen window and stare at the compost pile, but I think it kind of depends on your property. So there are some rules, guidelines, but nothing really hard and fast.
You mentioned that this is organic material, but what comprises a good compost pile?
Right. For most homeowners, what we're really talking about is plant debris. Like I said, industrial-wise, they compost, dead chicken, livestock, those type of things, but that's something we don't want to do in our backyard. It takes another whole level of management to handle that. So what we're really talking about is waste material from our gardens, whether that be vegetable garden, flower gardens. Could also be kitchen scraps, any of the food products that do not have fats and oils. So a good example is if you're peeling carrots, making a salad, all those could go into the compost pile. But once you put dressing on it, you got that oil, that fat on it, that probably needs to be discarded, not composted. And the other probably main ingredient is going to be those people that have to rake their leaves in the fall. We have fallen leaves. And those people that potentially catch their grass clippings would be the other main source of composting material for the average kind of homeowner.
Other than the oil-based, is there anything else that we maybe don't want to be putting into the compost pile?
Yeah, so things we kind of avoid composting when it comes to food waste is anything with fats and oils, meats, those type of things, because they're more likely to draw rodents and other less desirable critters to the compost pile. As a rule of thumb, we want to be really careful composting animal feces, especially our pets like cats and dogs, because there are potentials in disease transmission. But, if you've got a source of cattle, horse manure, those type of things, that actually can be good to add to the compost pile, because we haven't really touched on yet is what we call the greens and the browns, or the nitrogen sources versus the carbon sources, which is really then where the science/art of composting comes into play.
So go ahead, run through that. How do we kind of decide how much of each we need?
That's probably the biggest challenge for the most people when it comes to composting. What we're really wanting is kind of a mix of things that are greens that have moisture and nitrogen in them, and then the browns we normally think of being dry and being a carbon source, and probably need roughly about 2/3 carbon, 2/3 brown to 1/3 greens. But the problem with most people in composting is that they have a lot of browns. They have the dry plant materials, they have the shredded leaves, those type of things. And so then the trick or the challenge to composting comes in, where do we get our sources of greens? And that's where you can bring in, if you have some manure-based fertilizers, happen to be on a farm, those type of things, or you can use some garden fertilizer. You can then add some nitrogen to that mix so the compost pile will function and work. So really, as I said earlier, composting is really all about thinking of it as being alive. And what do things that are alive need? They need food, water, and shelter. And so the compost bin pile itself would be the shelter. Moisture is also very important for these microorganisms to work. And then that food source is the carbon, the browns, and the greens that feed the microorganisms that then break down the debris itself.
And we're actually building some heat with all of this process, right?
Right, yes. So if the compost pile is properly constructed, you've hit that kind of magic combination of greens and browns. After you build the pile, probably within a week to 10 days, that internal part of that pile should be reaching maybe up to 140 degrees or more. I mean, if you stuck your hand into a functioning compost pile, you would feel the heat. Or if you plunge like a shovel in there and left it in there for a few minutes and pulled the shovel out, the metal part would be warm. Because what happened is those microorganisms are feeding, they're giving off heat off their bodies, much like, when we overeat, we sometimes get a little sweaty or hot. Kind of the same things that's happened to those microorganisms. So that tells you the compost pile is functioning when you get that spike in that temperature.
Is that when we start the process of turning the compost?
Yeah, so let me back up and add one more kind of, if you're really trying to be what we call an active composter, or some people use the term hot composter, as opposed to more passive cold composting. So when you're building that pile, the other thing we want to add or make sure we have in there, besides a nice combination of greens and browns, is that moisture, that water component. Because really for a compost pile to function at its peak, you probably need that material in that pile to feel more like a damp sponge. So you really need that moisture throughout the entire composting process. So if you're building the pile from scratch, you may want to have a water source close by. So when you add that material, you can then soak it down and make sure it's wet. If the composting pile fails, it's usually because one or two reasons. One, we don't have enough nitrogen greens in there, or two, the composting pile is too dry. So yeah, if your system's working properly, when it heats up and then starts to cool down, that's when you turn the pile to kind of mix up that material. And then when you turn it, that distributes the fresh material for the organisms to break down. It gives you a chance to add more water, and then you should get another spike in temperature. So that's kind of what we call the compost cycle or the turning cycle. So it heats up, starts to cool down, we turn it heats back up, starts to cool down, we turn it again. And eventually then if you're an active composter, a hot composter, that's when you get that compost, in months instead of a year.
Well, that's what I was going to ask. What is the normal length before you can really start using the compost pile?
That is probably the $54,000 question that doesn't have a really good answer. Because the nice thing about composting is it's going to happen whether you do anything or not. So it gets back into kind of, like I said, the terminology I use before. Are you an active hot composter or are you a passive cold composter? So the more you monitor the pile, the more you make sure you have that balance of greens and browns, the more you keep a proper level of moisture, you may get compost in 3 to 6 months. If you're kind of pile it up in the back corner, go off and forget it, let Mother Nature handle the moisture, let just, nature handle the turning on its own, it may take a year before you get compost. It's a natural process. It happens regardless of what we do. I mean, composting happens in the forest floor, out in the pastures, the landscape all the time on its own. But composting is just managing it to make the process speedier or more efficient.
And I guess this really maybe the big question is, how effective is this as being used in the garden, and what are some of the primary benefits of composting?
Right. So the reason we want to kind of go to all this work to create compost is because it's that rich organic matter that is the end product. So if you fill up a big compost bin, kind of the standard size is 4 by 4 by 4, somewhere in that ballpark, so you have a big enough mass of materials for these microorganisms to live and break down, you're probably only get about a third of that pile back in the organic matter compost itself. And what organic matter has the ability to do is basically unlock the extreme hold all the clay particles in our soils have in Kansas. So if you go into our typical soils, you put a shovel in, you turn it over, it just kind of clumps in a big clod. So what organic matter compost does is release that kind of hold those clay particles in the soil have on each other. So you get that more rich, loamy type soil. If you ever, watch gardening programs, something like that, they put the shovel in and it just kind of comes out and kind of flakes apart. That's what organic matter compost does. It breaks down the clay, makes it more manageable. It also has the ability to add more water holding capacity to the soil, as well as aeration, making a more hospitable growing zone for roots of our plants. And of course, if we have healthy roots, we're going to have healthier tops of our plants.
And I guess kind of a side benefit is the fact that it keeps a lot of things out of the landfill.
Right. Here in Johnson County, in order, and I think Sedgwick County has the same rule, in order to extend the landfill space, we cannot put our organic waste into our trash stream. It goes into a composting facility. And so, one time it was estimated more than 10, maybe 15, 20% of what's going in the landfill is organic material, leaves, branches, grass clippings, those type of things, which can be easily, converted into compost. Many municipalities across the state of Kansas that have their own trash services do composting of debris, and some of the residents can get it free back as diverting that material. So, no one wants a landfill in their backyard, so the longer we can keep those things going, the better it is for our true trash stream as opposed to our recyclable organic waste stream.
And because so many people are doing this, Extension, of course, has publications.
Right. We have the information in written form. We also have some videos in our Healthy Yard section on composting that you can look at that gives you more ideas as far as what to add, the whole compost life cycle, the water, the turning, balancing those greens and browns for success.
That's K-State Research and Extension Horticulture Agent for Johnson County, Dennis Patton. To learn more about building a compost pile, visit the online K-State Research and Extension bookstore or contact the nearest county or district extension office. Sound Living is a weekly public affairs program produced by Research and Extension at Kansas State University. I'm Jeff Wichman, and this is the K-State Radio Network.